Okay, so the idea with these workshops here is that I will try every time to have a short example of something to clarify or something that I thought was missing from the lectures, and also give you an opportunity to ask questions on your assignments. So today I will try to make a less boring object orientation example. So I will try to do an object orientation with real purpose instead of just printing out stuff on the screen. So I'm going to use something called Pi5, which is a module for creative coding in Python. There's also an alternative tool that you can download called Processing, which is also a creative coding environment, but it does not use the same Python that we have in this course. So that's why I'm using this environment as a module here. So as you can see here, from Pi5 import sketch. That is the kind of basic method of doing it. I will show you some, I will in the documentation add how you can install it yourself and run it on your own computer, but come to that later. It's very simple user interface toolkit. Basically, it provides you with an empty canvas where you can draw things. And you can do that in real time. So it updates this canvas continuously. And the first thing we have to do here is to create a canvas or a sketch, as it's called. And you can see here the sketch here. So in this case, the first object-oriented thing you can see here is that we inherit the functionality from a base class called sketch. So that is the class that implements all the functionality. And then we specialize this class with our own needs. And basically what you need to implement if you want to do a sketch is you have to implement 3 methods: settings, setup, and draw. There is no need to do a init method in this class here. So you only have to implement it. And settings is just for setting up the window. So in this case, we will set up a window that is 600 by 600 pixels. We have a setup section here. That method is called once when you start a program and never more. So it's basically your initialization method in Python. And in this case here, we will add some stuff later on in my example. But the first thing we have to set is ellipse mode. It's when we draw ellipses that we want them to be centered instead of having upper left corner. So it's just something that makes it easier to work with. And then there is a method called draw that is called continuously all the time. So I think it's every 60th of a second. So it's a 60 hertz update. So it will draw continuously what's in the draw, the functions that are in draw. And in this case, I just have a background 40 that is dark gray. So this was a class. So to be able to use this, we need to create an instance, an object of that class. And what we do then is that we create here below here, there is I instantiate or create an object called P5 sketch from my class particle sketch. And in the next part, we do run sketch. That starts the program running, calling the draw method, calling the setup once, and so on. So if I run this program now, it will just bring up an empty window like this. But this empty window is continuously drawing here, so we will use that later on as a canvas for our drawing. So that was our particle sketch object that you saw here. So from this class method here, we created an object, P5 sketch, and then we run this sketch here. So the first thing we have to do, so my idea with this exercise is to implement a very simple particle system with particles that bounces off the walls. So it's not something very complicated. But if we think what we need something that can be drawn. We need to be able to specify color of the internal colors of the geometry, the line colors. So the first class I will define is something I call Drawable Base. So this base class will contain the properties of all my objects I want to define. So the colors and line thickness, and so on. So I define a class drawable base. It doesn't inherit from anything. By default, Python will always inherit from the base class object that you get without any effort. So you don't have to specify it explicitly. In earlier Python, you could see something like this that you inherited from object, but it's not required. It's implicit. Then we create a class constructor here. And here I will just set up some attributes to this object that we need for drawing. And I'm going to use the simple method I told before. I'm not going to do a lot of properties in this example. I will just define the attributes as variables directly. So we will have self. So when I create attributes to my object, I need to refer them to self so they're attached to the object you create. So we have first stroke color, and we define that as a simple list of color values. So we have 0, 0, 0. So in this Pi5, the colors are defined from 0 to 255. But meaning 255 is the full power of the color, so it will be complete red. 0 is no color. And then we also need to specify something called the transparency, alpha, which we set to 255, which we completely opaque. We also need to specify colors on the lines. No, sorry, this is the lines. The fill. So we have self fill color, and we do let's see here, do completely white like that, and we also do a self dot fill alpha. Like that. So now we have defined the basic attributes that we need all our objects to have. So every object, every class we create needs to have these attributes like the color and fill. We also need self stroke width here as well. And we do 2. Then we need a method for that we call to draw this. So def self. We have to specify on any class here. So the draw method is what we will call on the object to draw it. And here we need to set up the colors. And this is a bit strange here, but because I need to, all the functions for drawing is part of the particle sketch class. So to be able to access that, I have added declared it as global, so it's available for all the classes here. So here I do Pi5. And then I set and here I specify this. It has 3 options here, so I just put in self.stroke color 0. Then we have the fourth parameter is the self stroke alpha. Then we also have the fill color is done in a similar way, so we just copy it here and call this fill. Change this to fill color. I think that was the stroke weight as well. So as this is a drawable base, we have not yet defined what to draw. So it's kind of a base class for all the objects. So in this case, we want to delegate the drawing to the inherited objects. So we can do that by defining a method called onDraw that we make empty here. So in this case, onDraw pass is a method in Python that has no meaning except for it takes up space. So because you can't declare empty functions in Python, you need to have a way of putting something that doesn't do anything. So pass is just an empty implementation. It's a bit odd, but it works. And then at the end of the draw here, we call this function here. So self.on like this. And the good thing with this is that we don't have to call the method draw again to kind of make the field statements here. So we just say that stroke and field, that these are part of the object, and if you create an inherited object, you don't have to care about it. You just implement the onDraw method. So the draw method is part of the base interface of the object. So let's do a particle then. So now we need to do a particle, and now we need to implement inherit from the drawable base. So the particle will have stroke colors, field colors, and stroke width. So we inherit from drawable base. And the particle will need to have a position. So we give it input parameter. Let's put them to default values here as well. And then we set self x equals to x. We can also set, the particle should have a radius as well. So we add that directly here. So this is a combined object here. We set it to 1. So what we need to do now, we need to provide an onDraw implementation here. So we do def onDraw self, and we provide our own drawing routine here. So in this case, we do i5 sketch, and then we call ellipse. And ellipse takes the position coordinates and the width and height. So in this case, we do self.x. The height 2 times this one. The circle here, self.r, like that. And we don't have to specify the field colors and stroke color. That is handled by the drawable base automatically when you call the draw method. And the draw method will call onDraw, and we only have to provide this simple ellipse section here. So let's try out our. So in our setup, we need to create a particle. So we do self p equals to particle, and we put it on 200 by 200. So the coordinate system now is the window coordinate system with 0, 0 in the top left, and we put it in 200, 200, and we say it is give it 50 radius. We don't set any parameters. Otherwise, first here we just let it create it, and then we do self.p.draw. So hopefully I haven't done any errors here. So what happens here? Particle has no attribute. Stroke. You see what I did wrong? So I define an init for my particle, but I never call the initialization from the top object. So we need to initialize that as well. So super, which gives me the base object, init, like that. Now it has defined all these data structure that we need to be able to color it. So let's run. Very exciting circle. So a particle is not better than we need to specify some more attributes. So we need to be able to move this particle. We need to have some kind of speed. So we can do that as well. So we add we can specify self.vx equals to, let's see, we set up the 0 here first. Good. And then we have, we need to provide some kind of way of moving the particle. So we will add a method called update. And we need to also specify a time here. So self.delta time. And then we will do self.x plus equals to. That is an operator that does, instead of typing self.x equals to self.x, you can do plus equals to. That is automatic. And then we do self.vx plus self.vx times dt. Yeah, so then you don't have to specify self.x there. So that, and then we do self.y plus equals to self.vy dt. And then we know that the draw routine is called every 16th second. So we can then like that. And this should work. Let's see. Yes, moves over the screen like this. And we can also we can set the speed to 0 here to initialization, but we can in our initialization here we do self.p.vx. We set it to if my sketch contains a random function here, so we say it should be speed from 30, 100. So we do it from minus 100 to 100. So every time, no, it will probably have the same random number because the same seed. Yeah. We can also give it another color, self.fill color. It's like 25 times 0, 0. So why didn't it do that? No. This is Python. It's perfectly okay to add an attribute to an object. So what I did now was I added fill color to the sketch object. So I need to put P here like this. Then it adds it. So now it's red. So let's create many particles. So what we need to do first is we need to create a list of all our particles. So we do self.particles equals to an empty list like this. Then we do, let's see, for I in range 30. I do P, and then instead of doing self here now, I do move this up here. Then I remove self here, because we now the particle was stored in our list here. So at the end here, I will do self particles and P. And now we also need to update our drawing routine how, because it only draws one particle. So we have to do for P in self particles. So we should have 30 particles moving about. Hopefully in random ways as well, yes. But now you got the particles from a single position. So perhaps we should make the positions random as well. So let's do let me say 600. Now from we do a radius here from. You could also had created a particle just with an empty constructor here, and then use the attributes to set X and Y as well. So that is also something you can do. So let's see if it's a bit different now. So we have particles moving around here from random. It pass a bit big. I will do. You can also see here that the attributes are unique to each object. So when you create an object, the attributes attach to that object. So let's do fill colors differently as here as well. So we do then you can actually see that each object is really independent from each other. You have all the colors here. So, but we need to be able to make them stay in the box, so to speak. So let's see, now I'm going to do like the chefs that I copy pre-made things. This would be too complicated to do from scratch. So I have created something I call a box boundary. Which is where I want to kind of contain the particles in. So I have in this object it has attributes x min from 0 because that is the leftmost side of the window, and the max side is 600, and y min and so on. And then I have created a method here called check if the particles is inside the box. I also have implemented a global method here called check. It has an input method of a particle, and it will change the speeds when they come to the different boundaries, so make them basically bounce. And what I also want to do here, I have to create this object here. So let's see here. Now I did something really wrong. I added the class in the middle of the other class. That's not what I wanted. So let's see here if I put it after this one here, like that. And in my setup here, I also need to create self box equals to box boundary. I would call it better called boundary. Like this. I just used the default attribute here, but now that because I know that the window is 600 by 600. So I need to check here after the update. I will do self dot boundary check p. So the way I implement this, you can do this in different ways. You could have assigned a boundary to the particle, so a reference to the boundary in the particle instance, and then the particle itself could check if it's in the boundary, or you can make the particle as small as possible and check the particles afterwards. So that is a design choice. I don't say that either one is right or wrong, but if you have a large particle system, you probably don't want to have a lot of extra attributes in the particles. So this is also one way. So boundary check. And hopefully that should work. Yeah, so now you see that they are bouncing because I checked this boundary as well. So this is shows you many of the aspects of object-oriented programming. There is this inheritance that you inherit the fill and the stroke colors. We inherit we create an object for a class for handling the boundary. So boundary is a noun, particle is a noun, class, and make your algorithm's code more comprehensible. It's more logical. It's actually mimics the way that things work in the real world. So you update the particle, you check the boundary, you draw the particle, and we also have this, we store everything in a list that we loop over to implement. And then you can, of course, you could derive your own particles from the particle class. So if you want rectangle particles, you can create a particle and override the draw method of the particle class here. We also shown how you can delegate functionality by, so you define a base class that defines the interface of all your objects. And instead of overriding every method that you for every derived method, you delegate. So that we want users to be able to call draw. That is the main interface. Particle draw yourself. But we don't want to. Every time you override, you need to also override call the inherited draw. Instead, we define another method here called onDraw that we call inside our draw here, which is the one we override in the inherited classes. So the base classes should define the interface that you want to use, all objects to use, and then you, delegate the functionality to the inherited classes like this. And also, you saw here I just created attributes directly like this. I didn't use any properties, but it's possible to actually add properties to every of these classes afterwards. And you don't have to, it still will be compatible to the main algorithm here. So p.vx, if it's property or not, the user of that class doesn't know about that. So I have here a complete example that I have implemented with properties. So what you do then first is that you change your attributes that you use inside your class with a prefix __. And then you define the properties like this, just like I show you on Monday. And what you can do with this is, for example, one good way of using properties that you can actually check the properties, the values. So for example, if you only allow colors up to 255 and the user specifies 512, in the property assignment, you change that. It still works as a normal attribute assignment, but it automatically handles the error. The value checks the values and put them in the right value range. Same thing if you provide a color that is -255, you can say, okay, I set it to 0. So you can automatically handle all that stuff using properties. That is something you can't do when you just have attributes. But the nice thing is that you can start coding like this. Just add your attributes here, and then later you convert them to properties when you want to do more error checking and stuff like that. But it's very nice when you can do coding in a very light way directly without thinking about all the object-oriented things you need to implement. So that was what I wanted to show today, something that is a little more fun to do. So you can see that object orientation lends it very well to user interfaces and visualization, because it maps one-to-one to the concepts in here. So I will just stop recording now.